I'm pretty sure.
Hi everyone, welcome to this month's Satuccino. This edition is focusing on in-orbit servicing, assembly and manufacturing facilities. So thank you all for coming and thank you all for those online as well. I'm going to jump straight in with our first keynote speaker, Jeremy Hallell, who is our very own robotics development lead. Over to you, Jeremy.
Thank you. Good afternoon, everybody. You're giving me too many things to handle. Good afternoon, everybody. As Joe said, I'm the robotics development lead for the CAT. I normally reside over in our Westcott facility, so it's a bit of a rarity for me to come over to Harbour. I always forget how to get in. But I'm going to talk to you about our ISAM facility, and in particular the robotics we do at the ISAM facility, which is the most important part for us about. Or for me about ISAM. So the future of space led by robotics is kind of where I'm going with this. Why do we need robotics in space? Well, robotics thrive in harsh environments. We used to talk about the 3Ds, and one of those Ds is dangerous. And of course, space is a very dangerous environment to work in. And it's a very extreme environment. That's where robots really, really survive, where we don't need humans, we don't really want to put humans in there, and we don't need all those horrible things like life support and heating and air and all that kind of stuff. And by putting robots in space, we are enabling this scalable commercial activities. So robotics are going to be able to service satellites, refuel satellites, remove debris, and build the next generation of spaceships, space stations, and the like. And all around building this essential, sustainable space economy. Oh no, sorry, got too excited and showing you some videos. Go back. The other reason is robotics are cost efficient and accessible. And most of the challenges that we are going to present to a robot in orbit, we kind of solved here on Earth. I'm going to say most, not all of them, but most of them. The difference is we're putting that robot in a very, very different environment. And instead of being able to tell a robot what to do and tell it to do it 60 times an hour, as we would do in a car plant, we're telling it to do it maybe once a month or once a year. And we have to do it on the fly as we go. And that's the real challenge for robotics. But it does mean that we don't have to take all of that stuff that we need to keep humans safe in there. And long term, robots will also enable us to support long-term human presence, either servicing stations, going and doing the initial exploration on planetary bodies. You know, we've got Perseverance wandering around on Mars right now as a precursor to humans going to Mars. So why do we want to talk about ISAM facilities? So what's running in the background on the screen are some screenshots of our facility at Westcott, and this is what we call the ISAM facility. Most of this is all around in-orbit servicing and manufacturing. It's a unique European facility. There's nothing like this facility anywhere else in Europe. We've got very large-scale robots in here that enable us to carry really, really big components. That one there that was just on the screen can carry 120 kilos on its own. We operate an open access system, so anybody can come and use this facility, whether they're a very small startup company, a little bit more established, or a big international prime. We're designed to fit with them, and we can work through all of them, and we can do a huge amount of work. What's flashing through the screen is a snapshot of some of the stuff we do, and I'm going to try and snapshot it. So RPO and contact dynamics, more RPO. That's more contact dynamics, just a shot. Artificial intelligence learning for assembly of structures. So quite a big range of things that we do. The kind of the core capabilities we support, definitely rendezvous proximity operations. That's been the prime driver for what we do up there. Docking and capture is the next stage along. And this is almost like a timeline of where ISAM technologies actually are. So we're doing rendezvous proximity operations, we're doing docking and capture, we're moving on to refueling, servicing, repair, and assembly of large structures. They're kind of in parallel. The two bits at the end, development of autonomous robots and simulation, virtualization, digital twins, they're really important for the whole of robotics, not just for in orbit or on planet, but also for some of the supporting work that we do with our drone center up at Westcott and our autonomous connected Earth mission here hardware, where the autonomy that we put into the robots for in orbit has exactly the same application or the same technologies that we would apply for autonomous robots here on Earth. It's pretty much exactly the same technology. So there's huge crossover into what we do in those areas as well. All of this is backed up by simulation, visualization of digital twins, and huge amounts of AI, as you'd expect. I've only got a few minutes, so I'm going to stop on this one and say, look, the facility is there to help people de-risk their technologies. We talk a lot about robotics, but I was taking our commercial team around this morning. I said, you've got to actually in here forget about the robots. The robots are just a means to an end. They're a bit like a laptop with some software. This is your Dell laptop with Excel installed on it. Unless you know how to use Excel, it's a brick. It's not very useful. And that's our capability. That's the capability that we have in the team. We know how to use this robot. We know how to make Excel do your clever algorithms and data crunching and whatever it might be, or even a PowerPoint slide. So we can de-risk all that technology for you on Earth. We can validate all that technology and we can accelerate your development through to flight. I'm going around for the rest of the afternoon. So if you want to come and chat to me about robotics or ISAM, please do. Anya's also here, and Gary somewhere's around, part of the Beyond Earth team, also about ISAM, and Mark, sorry, didn't see that. We're all in part of the Beyond Earth team and can talk about ISAM as well. Thank you very much.
Next up, we have Calypso from Orbit Fab.
Try and do this with two hands.
If you want, I can.
So many hands. Yeah, I'll let you quick with that. Hello, everybody. I'm Calypso, the head of operations of Orbit Fab, and I only had 3 slides that I was allowed to give you. So you're going to get a bit of a brief, and I'm going to run through the slides in the 3 minutes that I have. Okay, so at Orbit Fab, we do in-orbit refueling of satellites. Why we might do that? Well, for decades, satellites haven't been able to be refueled, so that's very wasteful. It costs a lot of money because you're continuously setting up satellites, and it's adding to a lot of the issues that we already know that's happening within sustainability in space. It's adding to Kessler syndrome, the Kessler effect, and it's encouraging too many satellites basically being up in the space debris. So basically, what are we doing and how are we doing this? I lost my train of thought, but I realized we're on the next slide, so we're going to go with it. Okay, refueling transforms the satellite industry. And how does this do it? Like I said, it's an enabling technology. It's allowing us to work with other facilities and other elements within ISAM. So without being able to refuel, you can't do an ADR mission because you're just sending something up into space to get something out of orbit to then add to the satellite debris issue. Right, so we are enabling refueling through the concept of Rafty, this lovely little piece of equipment that my wonderful engineers at the back over there has built. So this works as think of your petrol hubcap on a car. You put this into your satellite design. Any satellite that uses propulsion systems needs to have a fill and drain valve. This replaces that. It's cheap. The low pressure variant of it is 30K, which sounds like a lot of money, but in the ground space of space, it's very cheap, right? So put this on your satellite, implement it into design. You can then have us refuel it in space later if you wanted to, at any point, because we'll then be able to use grasp, which I don't have with me, it's slightly larger, on a shuttle, and that can come up and cooperatively dock onto this little bit and do fluid transfer. Okay, I think they got to the next slide. Okay, we'll talk, I don't know how this, okay, we'll talk about the military aspects of space. Basically, we all know that the space sector is kind of moving towards a defense side of this, and it's very important and pertinent to the way that the geopolitical climate of space is right now. The Chinese adversaries have already started to refuel in space and shown that it's a concept that needs to happen. It needs to, essentially, like I said, there are lots of concepts of which refueling is very useful. It needs to happen because it allows us to enable freedom to maneuver. So if our adversaries are doing it and we're not doing it yet, we should be doing it because we can then defend ourselves and we can also move away and apply lots of different aspects of being able to refuel later. So, just a quick one on that and the importance of it. Got to the next slide. And I have already very briefly discussed how this works, but this is kind of our shuttle depot architecture. Essentially, we have RAFTI. In the US, it's qualified for low pressure variants of propulsion systems. That's chemical propulsion systems, things like hydrazine. We have now flight qualified in the UK for things like xenon, argon, any of your electric propulsion systems. So that means it hits the global and the European market. GRASP, our active interface, doesn't look like this right now, but that's what it looks like, sort of. That's kind of taken to the US one. But that will be on our shuttle, and that'll attach to RAFTI on our client satellite, refuel, move away. It can be done, I think at the moment, we've proof tested it to 100 times of refueling. Could be wrong. Again, ask them at the back. And then that's your mission life. It's extended. There's lots of different possibilities that you can do. It's very, very important. We do also work with Catapult and the ISAM yard, and we do work with a few other people that will be talking to you guys. We've got MagDrive and a few other things, like I said. It is an enabling technology so that you can work across different areas and continue to push into the circular economy. That 3 minutes.
Next up, we have Leonard from Cranfield University.
Thank you, everyone. Okay, so thanks for having invited me. I'm coming from Cranfield University. I'm a reader in space robotics and GNC in Cranfield University. And my role today is to present probably my baby, let's say, in a sense, like my lab, let's say. So the lab that somehow 3 years ago, I started developing thanks to some funding and project that we got in Cranfield. And somehow the lab is meant to be a facility for de-risking and validate technology for in-orbit assembly, in-orbit servicing, formation flying, rendezvous, docking, everything that the community here has probably can be tested in this small facility. Of course, it's a lab facility, but at the same time, let's say, in my opinion, it's quite interesting. The other role that I have is, of course, being a teacher. And I'm more or less using this lab, this facility, for developing the skills of new researchers, new engineers that probably will knock on your door, let's say, and ask for a job. And probably you are also requesting this. And that's more or less the other function of this lab. You can see here 2 of my PhD students that are somehow interacting with probably the first of my, let's say, babies, which is essentially Mario. From the accent, you can imagine why I called it Mario, but it stands for multi-arm robot for in-orbit operation. So yeah, it worked perfectly, and of course I somehow call it like this. Let's say I say okay, that's it. It is a 3-arm robot meant to, was built in order to as a function of a project, which is actually this one, funded by ESA and supported by Airbus and other European companies. In order to de-risk and raise the TRL of technology for in-orbit assembly in space, of big structures in space. Our role in Cranfield was actually to build the demonstrator, Mario, so my baby. Mario is a 3-arm robot, I already mentioned, with that can glide essentially on an epoxy floor in a almost zero friction environment. Why? Because we got air wings blowing air underneath, and it can glide hovering essentially in with a very tiny, let's say, made of air, let's say, in let's say over the floor. Over here, you can see what we can do. So we can do contact dynamics without any software or actuator in the middle. So real pure physics. we can test end effector. This actually was an end effector that some of my students developed in a project, let's say, just that finished just 2 weeks ago. I think that more or less that was the thing. And also, let's say, teach ROS, Gazebo, all the software that essentially is necessary for robotics. The other, my baby, is of course the lab. The lab, it's called Land, so that this way I can do Mario Light. And it's the laboratory for autonomous navigation and demonstration. And within the lab, of course, there is also the brother of Mario, Luigi. So low friction unit for in-plane GNC implementation, which is essentially a mock-up of a satellite that has thrusters, has some avionics sensors, and it can move around through essentially rendezvous and docking, formation flying scenarios. We can test technology such as sensors, even in this case, docking interfaces, and other things that probably are useful for all of you, let's say. We can do implement also GNC algorithm, test them, let's say, and so on. That concludes my talk. Of course, if you are having any interest on visiting the lab, please come to Cranfield. I'm always welcoming everyone, and so on. Thank you.
And next up, we have Aisha, who is, oh, there we go. Associate Project Manager at the Satellite Applications Casper.
Okay, so my name is Aisha Ashraf, and I'm Associate Project Manager at Catapult. So I'm here to talk about a project that we managed. We completed recently, and we completed it in April 2006. So before I delve into the project, I would like to talk about the challenges that is faced by the spacecraft maneuver and how our project contributed it, and how our ISAM facility that was shown by Jez has played a key role in executing this project. So as we all know, the spacecraft maneuvering is becoming more complex, especially while docking to another spacecraft or while refueling and while servicing, because these operations need a precise control of the spacecraft. And there are some challenges for this precise control. And one of the challenges that hinders the control is the fuel movement inside the spacecraft. So the fuel can slosh in the orbit, and it can move and oscillate as it doesn't settle like how it does on Earth. So even the slightest disturbance can make changes to its motion and pointing, which is going to affect its attitude and attitude and the trajectory. So it is really important that we need to measure and we need to understand and model the sloshing for the safety of the mission and its reliability. So here comes the role of the SLOSH-CAT, the project that we did. And the aim of the project was to measure the movement of the fuel inside the tank. And in order to do this, we used our robots in our ISAM yard to simulate the zero gravity conditions. So what we did was we collected the data from the testing and we used it to improve the digital simulation. So this simulation helps us to understand the movement of the fuel or sloshing of the fuel in the spacecraft. And it gives an understanding how to control the spacecraft in a controlled manner. So this was a project that was funded by UK Space Agency, and we partnered with Space Machines Company from Sydney. So they are planning to launch a spacecraft very soon, probably next year. And the other partner was University of Sydney. So they were the partner who led the simulation work. So how our facility contributed to this? So we did our testing from our ISAM yard. The testing was happening, it happened in the ISAM yard, but at the same time, the control was done by our engineers from our control room. So this allows them to observe, like, how does the fuel move inside the tank? We use the pressurized tank and the clear tank. How does it move and how does it interact with the spacecraft in a real time? So this will allow us to, so as I said before, it's going to help us to understand how to control the spacecraft. So and our ISAM facility is a specialized facility where we have our industrial robots, motion tracking, and gravity offload system. So with these equipments, we can do the close proximity maneuver like docking, servicing with satellite mockups. Apart from that, we can also do the inspection and repairing and refueling trials. So this means we can validate a technology before it is deployed in the space. And this positions UK in a unique capability for the future in-orbit operation. So this is the project, and this is how our ISAM facility has contributed to this project. Thank you.
Next up, we have Roman from the European Space Agency.
Thank you. Hello, everybody. I have 3 minutes, and usually I time my students when I ask them to introduce themselves, so I will do it for myself, if you don't mind. So I am the Spaceship XSAT coordinator, and you may ask, what is the spaceship? Well, actually, you have different spaceships all around Europe. There are teams, so Spaceship XSAT here in the UK, also Spaceship EAC, which was the first one. EAC stands for European Astronaut Center in Cologne, Germany. Spaceship FR in Toulouse for France, Spaceship PL in Poland, as you can guess. And our common ambition for all those spaceships is to prepare the future of space exploration. That's a small goal for us, for our small teams, but it's a good one, I think. And how do we do that? We imagine ourselves on the moon, on Mars. We look around us and we look at the technologies. What are the technologies that we need to live and work over there? Especially, what are the technology gaps that still exist nowadays? Luckily, those technology gaps were identified by a group of experts from all around the world, the ISAC, in the Global Exploration Roadmap. And then we look at new processes, new technologies that could help to fill those technology gaps. And so just for your information, the picture in the background is actually at the Luna facility at the European Astronaut Center. It's a 900-ton of regolith simulant where the astronauts can try some concept of operations, and we can test some equipment over there, rovers and others. What do we do here in the UK? Well, each spaceship has a flavor, and our flavor is a bit closer to robotics and extended reality. I will focus a bit more on robotics because today is the day for that. But yeah, we like to compare simulation with real case scenario. We have on site the Vulcan analog facility. It's a facility that is looking a center of expertise, let's say, for regolith simulant. Regolith, the dust that you see on celestial bodies, on the moon, on Mars, and others. Simulant, it's coming from Earth. So it's rocks from Earth that are like the one that you would find on the moon, on Mars, etc. So Vulcan help us with the expertise on how regolith simulant would handle scooping, for example, and then we simulate it and we try it. We also try to find some new innovative ways of gathering rocks on the moon. So we are going a bit further away from the ISAM topic. Let's go closer to the ISAM topic. Some other projects are actually linked with the Catapult Westcott. On the left here, some people in this room may recognize Uzair, who used to be with us last year, who simulated docking, so an assembly in orbit. And along with him was another student, Zoe, who designed and prototyped a different connector for in-orbit servicing or in-orbit assembly mainly. And with that, I cannot go into much more details because that's 3 minutes and 7 seconds. So I'm already over my 3 minutes. But thank you for your attention.
Thank you very much, Roman. And lastly, we have Nicholas from No Space.
Hello, everyone. My name is Niklas Dürr. I'm a manager at No Space, and we have been commissioned by the UK Space Agency to conduct this year's edition of the Size and Health of the UK Space Industry study. At the core of the study is an online survey targeted at all organizations in the UK space sector. And according to the director of the UK Space Agency, the study is the main source of evidence for their funding decisions. So therefore, it's very important that all the organizations, all the clusters, and all the subsectors are represented the right way in this study. Also ISAM. Especially against the background of the government's decision to go further and faster with the funding of ISAM, it's crucial that ISAM is represented properly in this study. The survey itself has been streamlined to only 7 questions this year. It used to be roughly more than 24 questions in the previous years. And the questions those 7 questions roughly center around income, employment, or funding that you might have received. And with preparing those figures, it should be possible to answer the survey in around 10 minutes. The survey will be open until the 26th of June and can be accessed by scanning this QR code or following the link provided down here on the slide. Sorry. Anyway, please don't hesitate to contact myself or my colleague if you have any further questions. And if you're interested in more details to the study, you can also access our project homepage, no.space/SH25. Thank you very much.
And thank you to all of our speakers for joining us, all in person today as well, which is fantastic. I'm going to shout a few upcoming events. So firstly, it's next month's Satuccino, which is going to be on the 3rd of June. It's going to be an unthemed event, so we should have a good mix of speakers. So look forward to that. Give that a second for people to get the QR code. Okay. And then a few other events going on in the industry. So firstly is the SmallSat Europe conference on the 26th to the 28th of May in Amsterdam. So it's one of the largest dedicated SmallSat events in the sector, centered on commercial, technical, and policy dynamics in the SmallSat market. It runs across 3 main agendas: commercial, defense, and technical, with a strong emphasis on investment, sovereign capabilities, mission design, and real-world deployment of SmallSat systems. Also, May is the Mobile Network Innovation Summit on the 12th to the 23rd of May on my piece of paper, but that's the 13th of May in London. This is a specialist telecoms conference focused on themes such as AI networks, satellite connectivity, quantum communications, and energy efficiency. And lastly, Geo Business, which is the 3rd to the 4th of June in London as well. This is the UK's largest event focused on geospatial data and location intelligence, covering how data is captured, analysed, and then applied across sectors like infrastructure, utilities, defence, and urban planning. So well worth keeping an eye out for. And with that, just want to thank you all again for joining us both in person and online, and look forward to seeing you in next month's Satuccino. Feel free to help yourself to be seated. Feel free to help yourself.
It's a new one. Io ti molto
Well, I mean, I worked out.
Yeah, that would be fantastic. No, I don't. Yeah, that would be great. That would be really great. It's so that I don't have to glasses. Oh, that's great. Okay. Lovely. Yeah, you do. Where we aligned, really, really, thank you. I'll take an email once I'm. Yeah, really good, thank you. Yeah, yeah, it's nice learning curve in terms of like industry strategy, education background. So like because every single thing is made, thank you. I'll send you an email. like how to scale and just because they'll make me today doesn't mean that it's going to be okay tomorrow. Yes. Yeah, but it's yeah. Yeah. So then that thing felt like it's good work. I don't, I think that's stay, like just each Yeah, honestly, it's my one thing that's driving. Drive over, coming out, and you're like, right. I don't even know I know. Yeah. Yeah, right now, I'm obviously on the culture part, but we're going back to the actual one. I want the content you found. Yeah, so, it's funny you said about the film. I was thinking about that. One way this was about that, how like I'm sure completely by like Hollywood movies made references. Like I don't know if someone on the script writing team or the production team about when they took that by accident. So I was thinking about we've got a delegation of and there's a bit in Armageddon where it's like the Russians, you never thought that they pick up on, and he's like, yeah, the crazy one, yeah. And he's like, there's a possible Russian. Oh, maybe Taiwan. And I was like, and like, and in the sci-fi, they don't know what it does, but maybe Taiwan. Oh, really? Yes. Yeah. 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 Yeah, reverse engineering. Yeah, yeah. I love yeah, yeah, he was so happy for doing it. It's really interesting. I mean, we're all screwed. But it was really interesting. Like, you come out of that going, one of the things we was the Chinese you know, the amount of power that the institute is exercising. Yeah, well, one of the case studies that they showed with the Russian authority who had, you know, all the legitimate credentials and everything because of placement in a UK university, they've been deliberately selected for university on the basis that they thought that one, they don't have a test they wanted them to.
I'm going to run away. No, what I just got the motorway every day. It's not as bad as on the way down. So when it was fine my way back. So I come M25, M4, and then I'm 58. So going the other way, that's too nice. I was about 60 miles because the going into Leicestershire. But it's all right, they just slowed us down. It's like a big, I've got it to use 7 hours, 10 of my last time.
Yeah.
Back to the old days.
No, wait, that's it, rush hour, extends to go like 7 and still on, and then 3 till 7, yeah. Yeah, so it's staying 2 hours at the minute. There you go. And that's pretty much random through. There we go. You know, just jumping my bed.
Yes, when I it was just after going to 13, 14, 15, 12 shop, and going into London and being on the fire for the about 6 hours.
Yeah, that takes me across.
Yeah, no, it was all right. It's only the next way on the way out. They slowed us to 40, drive by.
science. For some reason, it's not legally. I like to go home away, I know.
It wasn't going.
It's like that is bonkers. And it's like, I don't have to through it in my car.
Yeah.
The best way.
Yeah.
But I don't have a
Yeah.
then I felt like on the passenger seat next to me, if you're having to really follow it, like that's and so I'll just go next just go down the A34 and then go over the bit lining And you know, they say we do batteries, spend various things. Yeah. So he's handed it over now, so another one of our colleagues runs it now. Same thing, but it's just run by somebody else, yeah. Barry's still there. I was like, it literally. I haven't met well, we've only been on campus for like a month though, so she might be. Oh, we don't know, you tell me. I literally sat in a meeting like that yesterday, they came in and went, we need this, we like, desperate this. So we went, right, what do you need? Oh, well, what have you got? And I went, well, it's online. And one of the guys there had also done one course. And so we're like, we've done Barry actually went, you've done the course, you know, we did. And it's like, oh, right, okay. And then it's like, I was there literally like drawing it out of them one question at a time, just asking them questions, trying to figure out what it was. And yeah, I don't. We can probably do a bespoke offer for you. Yeah.
So they might have different things stuff. I'll be laying there at the street. That's kind of true. If we look at stuff, it's about
Yeah, so there's that side.
Well, one of the things is
Yeah, but we're looking at expanding that, so we're looking at trying to have like a introductory thing. So maybe for either new engineers or for people who work adjacent to like a project manager, something like that, have some understanding of what's going on, but don't need to be really in the detail. So like having that kind of overlap, then you've got your SAT on top of it, and then we're looking at also adding like a mill SAT, like a 2 or 3 days. So like say you have a SAT, so you would then look at doing the mill SAT on top.
Years ago. They bring that back together. Yeah. Tony Williams. Yeah.
So therefore, what is?
No, it's humanity, by and stop faster than
Like those.
big head of and so on. Which are broader, so like, yeah, that foundation and just kind of,
Like 1 or 2 day topic.
yeah. 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 Yeah, yeah, so I think those broad ones are quite interesting.
Are you going to the furniture?
Yeah.
That's why I built that always went structure.
Conversation yesterday. To do, yeah, yeah, yeah. It's built to do that, yeah, yes. And then having like that's in place, like I sat in the meeting yesterday, and one of the guys that was meeting went, oh, it'd be really interesting if there was like some training on like simulation. And the academic next to me.
Yeah. 15. I don't know what it is.